Alright, so today I'm going to go over the Unit 6 practice test. So this is the practice test on scatter plots and two-way tables. And so if we look at the first question, it asks us to label each plot with the relationship shown. So when it's talking about relationships, it's talking about positive, negative, no relationship, linear, non-linear. So if we look at problem number A, we can see that it is going downhill when we read it left to right. So as the x value is increasing, the y value is decreasing. So this is a negative relationship. Let me get a marker that writes. So 1A is a negative relationship. Negative. Alright. So 1B, they're random, there's no pattern to it, so this is what we would just call no relationship or no association. Number 1C, it's going uphill when we look at it left or right. So as the x value is increasing, the y value is also increasing, so this is positive. When they're doing the same thing, it's positive. When they're doing opposites, it's negative. And then this one right here, you can kind of see this U-shaped or parabola type pattern, so this is just going to be a non-linear relationship. And remember that linear means straight line. Alright. Problem number 2. Describe the relationship shown in this scatter plot, shown by this scatter plot. Well, first of all, the relationship is negative. It's going downhill, x is increasing, y is decreasing. So I know that it's a negative relationship. Alright, and then it asks me, it says, as the practice time increases, the blank. So it wants us to finish that sentence. So I'm going to scroll up a little. So as the practice time increases, what do we see happening to the y value, which is mistakes, okay, number of mistakes played. So as the practice time increases, the mistakes come down. So we would list this as the practice time increases, the number of mistakes decrease, okay. Negative, they're doing opposite. One of them has the increase, one of them has a decrease in a negative relationship. 3. What does the point 2, 8 represent in this scatter plot? So if we look right here, 2, 8. So we need to kind of talk about the rise and the run. So it's the 8 is your rise, and it stands for the mistakes, and the 2 would stand for the time practiced. All right, so when we start talking about these things, we generally talk about the x value first, which is the independent value. And if there's time involved, time should always be down here on the x-axis as the independent variable. So 2 hours would equal 8 mistakes. That's what it's saying. So when it asks you what does the 0.28 represent in this scatter plot, it represents that 2 hours of practice would equal about 8 mistakes. Number 4. What is the relationship between the temperature outside and the number of people wearing coats? Well, as the temperature goes up, what happens to the people wearing coats? Do they go up or do they go down? Okay. As the temperature goes up, the number of people wearing coats goes down. So those are opposites. That's a negative relationship. The opposite of that is also true. As the temperature goes down, the number of people wearing coats goes up. Okay? So this is a negative relationship. 5. So this is negative. What is the relationship between the minutes you are in the shower and the amount of water you use? So the more minutes you're in the shower, so as the minutes increase, the amount of water you use also increases. Both of them are going up. They're doing the same thing. That's a positive relationship. 6. What is the relationship between the number of siblings a person has and their grade on a math test? Well, there is no relationship. So this would just be no relationship. All right. The graph below shows the relationship between the distance in miles a delivery truck traveled and the number of hours each delivery took. Alright. Number 7, what is the y-intercept? Alright, the y-intercept, also known as the initial value, is right here. So where does that function line intersect the y-axis in its 4 or 4 hours? Either one. What is the slope? Well, we need 2 good points, and we can use this as a good point right here. So we need its ordered pair. So this one is going to be 0, 4. That's its ordered pair. And we need another good pair, ordered pair, another good point. And we're just kind of scanning this line, looking for it to intersect really well. Actually, let me scroll that down just a touch so we can see the whole thing here. All right, and it looks like we have a good point right here. That looks like a good point. And that would be 600, 10. Now, it would be okay if there's not a dot there. Anytime that line falls perfectly on an intersection. In fact, looks like that 408 would also be a very good point that we could have used. But needless to say, I'm already using this one. So if I want to find the slope of this, I need to do the y2 minus the y1. So y2 is 10 minus y1 is 4 over x2 minus x1. So I get 6 over 600, which simplifies into 1/100th. So what is the slope? 1/100th. And then it says write the equation of the line of best fit. And so that would be y equals, now we need our slope, 1/100th, followed by an x, plus our intercept, which in this case is a positive 4, so it's going to be plus 4. So there's the equation. The next question, what does the slope mean? Not what is the definition of slope, or even what is the slope for this problem, because we already know that the slope is 1 over 100. But what does it mean for this actual problem, this whole scenario with this delivery truck? And a lot of you first came to the conclusion that it means that the 1 stands for hours, and the bottom down here, the 100, is the miles. And so immediately, which it does, that's true. And so immediately you said it means that he goes 100 miles in 1 hour. And then I ask you to think about that. A delivery truck traveling 100 miles in just 1 hour to make a delivery. And it's not very likely, okay? And the part you're leaving out is where we started from. It says that at 0 miles away, it would still take 4 hours. So if it was next door, it's still going to take 4 hours to deliver it. So you need to kind of really examine this scenario. So while it does say that 1 hour and 100 miles are linked together, in this case, it doesn't mean that you're going to get a 100-mile delivery in just 1 hour. Okay? In fact, if you look at the 100-mile mark and go up, it states that it's going to take about 5 hours. Okay? So it's going to take about 5 hours to get a 100-mile delivery. So saying that they can make a 100-mile delivery in 1 hour doesn't even fit the graph. All right. So what it's actually telling you is that there is a 4-hour initial value, meaning no matter how far or how close you are, it's a minimum of 4 hours. Now the slope tells me that there is going to be an additional 1 hour for every 100 miles of travel. So there's the initial 4 hours, and the slope says that for every 100 miles from the store, it'll take an additional hour to get your product there. So if it was going to be a 400-mile delivery, it's going to take the 4 hours because of the 400 miles, but it also takes into account the 4-hour minimum. So a 400-mile delivery is an 8-hour trip. So the answer to the question is, what does the slope mean in this case? It's going to be an additional 1 hour for every 100 miles from the store. Every 100 miles of delivery is an extra hour, an additional hour. Page 2. The scatter plot shows the average yearly consumption of bottled water by people in the United States starting in 1990. How many data points show less than 12 gallons? Alright, please keep in mind that this is just a corner of the graph. It's not actually a data point. The squiggly line that you see right here just indicates that part of the graph is missing, and they're indicating that they didn't start at 0, that they skipped some numbers. So that's the squiggly line. So how many points show less than 12 gallons? Well, here's the 12-gallon mark, and that we see 1, 2, 3 points below that. So it would be 3. Using the trend line, predict the average consumption of bottled water in the year 2000. So all we need to do is go to the year 2000 and go up until we meet the trend line, and then go to our left to predict that amount. So we hit the trend line here, we go across, and that would be 19. So 19. And in this case, it would be gallons of bottled water. So you could even say 19 gallons. Write the equation of the trend line. Okay. Well, we do have some of the information. We know it's y equals. We know there's going to be an x in there, and we know right here that the intercept is a positive 10, so it's going to have a plus 10 on the end. So this point would be 1990, comma 10, and we need one more good point. And as I scan, it looks like that year 2000, if you take a look at that, looks like it might have been a very good point. It's on our line, looks very good right there. So I'm going to use that one. I'm going to use 2000, comma 19. And so using those two coordinates, we're going to have 19 minus 10, y2 minus y1, over 2000 minus 1990. So that's x2 minus x1. I get 9 over 10, 9 tenths. That is my slope, 9 tenths. So there is the equation of the trend line. Remember, you're not looking for a point that's perfect. If there is a perfect point on your trend line, great. If not, just find a good intersection that your trend line goes across. And it looked like the 2000 was a very good intersection. It looks like it fit perfectly. "14, what relationship does this scatter plot show?" That particular scatter plot is positive. It's going uphill left to right. As x increases, y also increases. So answer 14 is positive. 15, describe the relationship between the distance of a flight and the price of an airplane ticket. All right. So as the distance increases, the cost of the plane ticket also increases. But right here, they're both, we could probably estimate and just say $200 and 200 miles if we wanted to. And as the numbers increase, we can put some numbers on here if it helps. You could say that this was 500, 1,000, 2,000. And if we start going up here, and maybe this ends up with $1,000 up here, you can see that as the dots get further out, increasing, they're also higher up. So the distance is increasing and the cost is increasing. So when they're both doing the same thing, that's a positive relationship. So when it asks us to describe that, we could say it is a positive relationship where as the distance of the flight is increasing, the cost of the plane ticket is also increasing. So good math words would be increasing and decreasing in this case. As the distance of the flight is increasing, the cost of the plane ticket is also increasing. 16. What is a cluster? A cluster is a group of points that are close together. It's that simple. A cluster is a group of data points that are close together. 17. What is an outlier? An outlier is a point that is far away from the other data points. Okay? It's simply a data point that is far away from the other data points. 18. What is the difference between interpolating and extrapolating? Easy? Okay. Let me pause it. All right, we'll pause there for a second.